Okay, so today we're going to go over the percent, actual, and theoretical yield worksheet. So number 1, it says, I began this reaction with 20 grams of lithium hydroxide. What is my theoretical yield of lithium chloride? Okay, so first it's telling me that I began with 20 grams of lithium hydroxide. This is lithium hydroxide. I have 20 grams. Okay, and it's asking for the theoretical yield of lithium chloride. Lithium chloride is this guy. Theoretical yield, remember that is the maximum amount of product that you can make. You get the theoretical yield from doing stoichiometry and looking for the grams. Okay, so here what they're really asking us is question mark grams. Okay, so I'm going to start with 20 grams. So first I'm going to do stoichiometry and convert 20 grams of lithium hydroxide to grams of lithium chloride. So I have 20 grams of LiOH. Since I am in grams, the first step that I'm going to do is turn that into moles so that then I could use a mole ratio. Okay, and remember that I am going to go from grams to moles using the molar mass of LiOH. So lithium has a mass of 6.94. Oxygen has a mass of 16, and hydrogen has a mass of 1.01. So I'm going to add all of those masses together, and it's going to give me a molar mass of 23.95 grams of LiOH for every 1 mole of LiOH. Okay, remember that this number, I got it by adding the mass of the lithium plus the oxygen plus the hydrogen according to the periodic table. So lithium plus hydrogen plus oxygen. I put the grams in the bottom, so like this, grams of lithium hydroxide cancel each other out, and now I'm left in moles. Okay, now that I'm in moles, in every stoichiometry problem, once you're in moles, the next step is going to be to use the mole ratio. Okay, and this mole ratio comes from your balanced chemical equation. And according to my balanced chemical equation, there's 1 mole of LiOH for every 1 mole of LiCl. Okay, I put the moles of lithium hydroxide in the bottom, so like this they cancel each other out. Okay, now I'm in moles of LiCl, but remember they asked me for the theoretical yield, and that is in grams. So I'm going to do one more step in which I go from moles to grams using the molar mass of LiCl. Okay, and I do this by adding the mass of 1 lithium, which is 6.94, plus the mass of chlorine, which is 35.45. I add those two masses, and it gives me 42.39 grams of lithium chloride for every 1 mole of lithium chloride. Okay, in this case I put the grams in the top. Remember, I wanted the moles in the bottom, so the moles cancel each other out. Now I am done. All I need to do is calculate this. So I'm going to get my calculator and do 20 divided by 23.95, and then multiply that by 42.39. And my calculator gives me 35.3987 grams of lithium chloride. And that is my theoretical yield. Part B says I actually produce 6 grams of lithium chloride. What is my percent yield? Okay, so now here they're giving you the actual yield. In part A, we calculated the theoretical yield, right? Theoretical yield. Now they're giving us the actual yield, and they're asking us for percent yield. Well, we know the formula for percent yield is at actual over theoretical, I'm just going to write theo, times 100. Okay, the actual was just given to us, 6 grams of lithium chloride. Okay, the theoretical, we calculated for it right here, 35.3987 grams of LiCl and times 100. Notice how the unit and the element are the same, the compound. So the unit and the compound are the same, so they cancel each other out. So now I'm going to get my calculator. I'm going to do 6 divided by 35.3987 times 100. And it gives me that my theoretical yield is 16.95. 16.95% of lithium chloride. That is my percent yield. Now number 2 says if I start with 5 grams of C3H8, so if I start with 5 grams of this guy, what is my theoretical yield for water? Okay, so they're asking me for the theoretical yield of water. It is important because remember last time when we were doing limiting or excess reactant, we were able to choose whichever product we wanted. Here, the product is being chosen for us. Okay, so we're going to solve for water, grams. Remember that my theoretical yield, so this theoretical yield of water comes from the limiting reactant. Okay, so that means that oxygen is in excess and C3H8 will be my limiting reactant, because the limiting reactant is going to be the one that tells me how much product can I actually make. Okay, so the limiting reactant, the reactant that produced the least amount of product, that's going to tell me the theoretical yield. It's going to tell me how much should I be making. Okay, so I'm going to do stoichiometry to go from grams of C3H8 to question mark grams of water. I'm going to start with the 5 grams of C3H8. And now since I am in grams, remember that my first thing, if I'm in grams, is I need to convert that into moles so that then I could use a mole ratio. So my first step is going to be to find the molar mass of C3H8. So let me do it on a pen. So carbon, I have 3 times the mass of carbon. Hydrogen, I have 8 times the mass of hydrogen, which according to the periodic table is 1.01. Times 8 is 8.08. Carbon, the mass of one carbon is 12.01. Times 3, because I have 3 carbons, is 36.03. I add these two and I get 44.11 grams per mole. So now I'm going to put this number here in the bottom, 44.11 grams for every 1 mole, and 1 mole in the top, C3H8. Okay, the reason that I put the grams in the bottom is so that grams and grams cancel each other out. Now I'm left in moles. Okay, now that I'm in moles, now I could use our mole ratio. Remember, that comes from the balanced chemical equation, the coefficient. So for every 1 mole of C3H8, there are 4 moles of water. 4 moles of H2O. I put the moles of C3H8 in the bottom so they cancel each other out. If you write the unit and the compound, you will know when do you have to multiply, when do you have to divide, because the units are going to tell you where should this 4 go. Okay, it has to go in the top because in the bottom we want moles of C3H8. Okay, but now that we use the mole ratio and we went from moles of C3H8 to moles of water, Now we just need one more step to go from moles of water to grams of water. And that step involves the molar mass of water. Molar mass of H2O. So we're gonna take the mass. I'm gonna get my calculator again. Take the mass of hydrogen, there's 2 hydrogens, times the mass of 1 hydrogen, which is 1.01. It's 2.02, plus the mass of 1 oxygen, which 1 oxygen is 16. So plus 16.00, 18.02. So the molar mass of water is 18.02 grams per mole. Okay, now do we want to put this number in the top or in the bottom? This number is 18.02 grams. Since here we have moles, in the bottom we want to have 1 mole, and in the top we're going to write 18.02 grams of water. Okay, the reason that we want to put moles in the bottom is so the moles of water and moles of water cancel each other out. Now that the only unit left is grams of water, what the question is asking us for, we're done. We're going to get our calculator again. And if the number is in the top, we multiply. If the number is in the bottom, we divide, always starting from left to right. Okay, so we're going to start with 5. The next section, we have a number in the bottom. So that means that we're going to be dividing by 44.11. In the next section, we have a 4 in the top. That means that we're going to be multiplying by 4. Remember the ones, we don't really need to do it because whenever we divide by 1 or multiply by 1, we get the same answer. And then the next step, we have a number in the top. That means that we're going to be multiplying by that number, which is 18.02. And that gives us that we have 8.17 grams of water. And that is our theoretical yield. So our theoretical yield of water is that we should be making 8.17 grams of water. Okay, now part B says, I got a percent yield of 75%. So here they're giving us the percent yield of 75%, and they're asking us for how many grams of water did I make. Okay, so what they're actually asking us for is for the actual yield. So they're asking us for the actual yield. Okay, because they gave us a percent yield, and we know that percent yield equals at actual over theoretical, theo, times 100. Okay, so in this question, they gave us the percent yield, 75%. The theoretical yield, we already calculated it in step 1. The theoretical yield of water, we calculated it. 100 stays there, so what we're looking for is the actual yield. Okay, so what I'm going to do now is I'm going to plug in all my values into this equation. So my percent yield is 75. So I'm going to write 75% equals actual. Since I do not know my actual, I'm going to put that as an x. So my actual is my x, what I'm trying to look for. And my theoretical, I calculated it in step 1. It was 8.17 grams of water. And then times 100. Okay, so the first thing I'm going to do, you could do this. There's algebra, right? You're solving for x. So there's many different ways that you could do it. The first thing I'm going to do is I'm going to get rid of this 100. Because remember, I want to isolate x. So the way to get rid of this 100 is by dividing both sides by 100. So here my 100 goes away. I'm going to do 75 divided by 100. I get 0.75. 0.75 equals x over 8.17 grams of water. Now, how do I isolate x now? Well, right here I have x being divided by this number. So to get rid of this number, I'm going to multiply it on this side. Okay, so I'm going to do 0.75 times 8.17. And it gives me that X 0.75 times 8.17, and it gives me that X equals 6.13 grams of water. So that my actual yield is 6.13 grams of water. Okay, and if I want to check my work, I could do actual over theoretical times 100, and I should get 75%. 6.13, which is my actual yield, divided by my theoretical, times 100, 75%. Okay, so I know I did it right. Number 3 says, my theoretical yield for beryllium chloride is 10.7 grams. If my actual yield is 4.5 grams, what is my percent yield? Okay, so this one is actually pretty easy. They're already giving me all my components. Okay, they're giving me the theoretical yield, they're giving me the actual yield, and they're asking me for percent yield. So percent yield, I'm going to rewrite the formula one more time. Remember, that is actual over theoretical times 100. So all I have to do is plug in the values and calculate it. My actual yield is 4.5 grams of beryllium chloride, BeCl2. The theoretical yield is 10.7 grams of beryllium chloride, and then times 100. Like this, grams cancel out. So all I have to do is do 4.5 divided by 10.7 times 100, and it's going to give me 42.06% of BeCl2. And that's my final answer. That's my percent yield. Number 4 says, what is the theoretical yield of sodium oxide? Okay, so they're asking me for the theoretical yield of sodium oxide. Sodium oxide is going to be sodium and oxygen together. So sodium, that's not an oxygen. Sodium oxide is this one. Okay, so they're asking me. Anyway, since they're asking for a theoretical yield, I should have known that it's on the product side. Okay, so they're asking me for the grams of this guy. Remember that every time they're asking you for the theoretical yield, they're asking you for grams of sodium oxide. If I start with 20 grams of calcium oxide, calcium, Ca, oxygen is O, so is this. If I start with 20 grams of calcium oxide, how much product in grams am I going to produce? How many grams of sodium oxide can I produce? What is my theoretical yield? Okay, so I'll have to do stoichiometry, starting with 20 grams of CaO. Now, since I am in grams, my first step is going to be to use the molar mass of CaO. Calcium and oxygen. Oxygen has a mass of 16. Calcium has a mass of 40.08. 40.08. When I add both of these together, I'm going to get 56.08 grams per mole. Okay, so now that number, I'm going to put it in the bottom because since I have grams here in the top, in the bottom, I want grams. Grams of CaO for every 1 mole of calcium oxide. Like this, the grams cancel each other out. Now I'm left in moles. Now I'm going to use my little friend called the mole ratio. in which I look at the balanced chemical equation. There's 1 mole of CaO for every 1 mole, right, because no number here, of Na2O. The moles of CaO get canceled out. Now I'm in moles of my product, but I want to do one more step in which I go from moles to grams. And I do that by using the molar mass of Na2O. So I have sodium, 2 of them, times the mass of 1 sodium, which is 22.99. Oxygen, I only have 1 times 16, 16.00. 2 times 29.99 is 45.98. I add and I get 61.98 grams per mole. Okay, now this number, I'm going to put in the top. And the reason is because since I have moles up here, I want moles in the bottom. So 1 mole of Na2O for every 61.98 grams of sodium oxide. And like this, the moles get counted out. So now my final step is to get my calculator and calculate this. So I'm gonna get my calculator and I'm gonna start in the beginning. I'm gonna start from left to right. I'm gonna start with 20. Okay, now my next little section, they have a number in the bottom. So I'm gonna divide by 56.08. In my next section, I have 1 over 1, multiply by 1, divide by 1. I don't really have to calculate that because it's gonna give me the same number. And then in my next section, I have a number in the top. That means that I'm gonna be multiplying by 61.98. And I get that my theoretical yield is 22.10 grams of Na2O. Okay, that's my theoretical yield, and I am done. Okay, number 5 says, what is the theoretical yield of iron 2 chloride? So theoretical yield of iron 2 chloride. Theoretical yield, that means there's going to be someone in the product. Iron 2 chloride, this guy. So we need to look for the grams of iron 2 chloride. So how much product in grams can I produce if I start with 34 grams of iron 2 bromide? Iron is Fe, bromide is Br, FeBr. Okay, so if I start with 34 grams of iron 2 bromide, how much product, how much iron chloride in grams can I make? Okay, so I'm going to start with 34 grams of FeBr2. Since I'm in grams, my first step is going to be to turn those grams into moles by looking at the molar mass. Molar mass of FeBr2. Okay, so I'm just going to do it on my calculator. I have 2 bromine. So 2 times the mass of bromine, which is 79.9, plus I have 1 iron, so plus the mass of 1 iron, which is 55.85. And I get 215.65 grams of FeBr2 for every 1 mole of FeBr2. Now that I am in moles, right, because the grams got canceled out, now that I am in moles, I could use my mole ratio. So now that I'm in moles, I'm going to use my mole ratio. And my mole ratio is that I have 1 mole of FeBr2 for every, since there's a number in front, that means there's a 1. 1 mole of FeCl2. The moles of iron 2 bromide get cancelled out. Now I'm in moles of my product. But remember, they're asking for the grams. So So I need to do one more step. I need to calculate the molar mass of FeCl2. Okay, so I'm gonna again use my calculator. I have 2 chlorine, so Cl is chlorine. Each chlorine has a mass of 35.45. So I'm gonna do 2 times 35.45 plus I have 1 iron, and iron has a mass of 55.85. 55.85, and that gives me a mass of 126.75. In this case, I'm gonna put in the top 126.75 grams of FeCl2 for every 1 mole of FeCl2. Okay, like this, the grams get canceled out. Sorry, the moles get canceled out. I am left in grams. Okay, so my final step is to calculate all this. I'm gonna get my calculator, starting with 34. Now in my next section, I have a number in the bottom, so that means that I'm gonna be dividing by 215.65. My next section is 1/1, so I don't really have to do anything. And in my last section, I have a number in the top. That means that I'm gonna be multiplying 126.75 equal 19.98 grams of FeCl2, and this is my theoretical yield. Okay, part B is saying what is the percent yield. So now they're asking me for the percent yield of iron 2 chloride. Iron 2 chloride, I just found the theoretical. I'm sorry, theo. I just found out the theoretical yield. Now they're asking me for percent yield. Remember that percent yield is at actual over theo times 100. Okay, so what is the percent yield of iron 2 chloride if my actual yield is 4 grams? So they're giving me the actual. I know the theoretical yield because I just calculated for that in step A, and they're asking me for my percent yield. So I'm just gonna plug in all my values. Okay, so percent yield equals actual. I do not know, that's what I'm trying to figure out, so I'm gonna put X over theoretical, which I calculated it is 19.98 times 100. Okay, so I went ahead of myself. They actually do give me the actual yield. So actual yield is 4 grams. Okay, so all I gotta do is do 4 divided by 19.98 times 100, and my percent yield is 20.00% of FeCl2, and that's my final answer. Okay, number 6 says, what is my percent yield? So they're asking me for the percent yield of titanium 2 oxide. Titanium is Ti, oxide is oxygen. So they're asking me for percent yield of this guy. Okay, so the percent yield for titanium 2 oxide. If I start with 20 grams of titanium sulfide. So if I start with 20 grams of titanium, which is Ti, sulfide is S, so it's this guy. If I start with 20 grams and my actual yield is 22 grams, what is my percent yield? Okay, so they're giving me the actual yield. They're giving me the actual yield. And they're giving me how much product I'm starting with. So the first thing I need to do is I need to find my theoretical yield. So then I could divide my actual divided by my theoretical times 100 to figure out the percent yield. Okay, so first I need to do stoichiometry. 20 grams of TiS. And I need to convert that into grams of TiO. The way I do that is by doing stoichiometry. My first step, since I am starting off in gram, is to use the molar mass and divide by it. Okay, so I'm going to get my periodic table. Ti is titanium. It has a mass of, where's titanium? 204.38. 204.38 plus the mass of 1s, 1 sulfur, 32.07. And that gives me a molar mass of 236.45 grams of TiS for every 1 mole of titanium 2 sulfide. Like this, the grams get canceled out. I'm left in moles. Now that I'm in moles, now I could use my mole ratio to go from one compound to the next. And here the ratio is 1 to 1. Okay, so I have 1 mole of TiS for every 1 mole of TiO. Like this, the moles of titanium 2 sulfide are gone. I'm left now in moles of TiO. Okay, I need to find the grams. So now I need to figure out the molar mass of TiO. Again, titanium has a mass of 204.38 plus the mass of 1 oxygen, which is 16. And that gives me a molar mass of 220. And I'm going to put that number in the top. Okay, so 220.38 grams of TiO. The reason that I put it on the top is because in the bottom, I want moles. Okay, the reason that I want moles is so the moles and moles cancel each other out. So now my final step, since I'm already in grams, is to multiply and divide all this. So starting left to right, starting with my first number, 20. In my next step, I have a number in the bottom. That means that I'm going to be dividing 236.45. In my next step is 1 and 1. If I multiply by 1, divide by 1, I get the same answer. So I don't have to do that step. On my final step, I have a number at the top. That means that I'm going to be multiplying by 220.38 equal. And this is going to give me my theoretical yield. So my theoretical yield is 18.64 grams of TiO. Okay, and that is going to be my Theo. This question is asking me for percent yield. Okay, so remember the percent yield is actual over theoretical times 100. They're asking me for the percent yield, and they gave me that the actual was 22 grams. So now I'm just gonna plug everything in. Okay, so plugging everything in. Actual, they gave it to me, 22 grams of tin 2 oxide divided by my theoretical, which I just calculated it, 18.64 grams of tin 2 oxide times 100. Okay, so when I do that, 22 divided by 18.64 times 100, I notice that my percentage is way bigger than 100%, okay? So this is a trick question. This is the answer that you should have gotten, but this is never gonna happen in real life, okay? So I had a lot of you guys asking me if this was right, that they kept doing it and doing it and they kept getting something that's more than 100%. The answer is correct for this problem, but this is never going to happen in real life, okay? Okay, number 10 says, what is the actual yield of uranium hexabromide if I start with 10 grams of uranium and get a percent yield of 83%, okay? So there's a lot of stuff going on here. So they're telling me that I start with 100 grams of uranium, 100 grams of uranium, and get a percent yield. Okay, so they're giving me the percent yield. And what the question is actually asking for is, what is the actual yield of uranium hexabromide? So uranium hexabromide is this guy. So they're asking me for the actual yield, okay? They're giving us a percent yield. Remember, the percent yield is actual, which is what they're asking me for, over theoretical. Let me just write it down. So percent yield, let me write it down here. Percent yield, again, is actual over theoretical times 100. Okay, so they're giving us percent yield. They're giving us that 83%. The actual yield, that's what they're asking us to find. So they're asking us to find the actual. We do not know that. The theoretical yield, it's not given to us. So this is not a theoretical yield. This is how much we start with. So they don't give us the theoretical yield, but we can figure that out using stoichiometry. Okay, so I'm going to put a little check mark here because that's the first thing that we have to do. We need to figure out the theoretical yield by doing stoichiometry. Okay, so we're going to start with 100 grams of uranium, which is U, and we're going to convert that into grams of uranium hexabromide, and that's going to give us our theoretical yield. Okay, so since we're in grams, the first step is going to be to turn that grams into moles by dividing by the molar mass of uranium, which is just 1 U, it's just 238.03. So 238.03 grams of U for every 1 mole of U. Like this, the grams get canceled out. Now that I'm in moles of U, now I could use the mole ratio. Okay, and the ratio is that I have 1 mole, 1 mole of U for every 1 mole of UBr6. Like this again, the moles of U get canceled out. I'm left in moles of my product, but I need to figure out the grams in order to have the theoretical yield. Okay, so I need to figure out the molar mass of UBr6. Again, I'm gonna get my calculator. So bromine, I have 6. Okay, so I'm gonna do 6 times the mass of bromine, which is 79.90, plus the mass of only 1 uranium, which is 238.03. And that gives me a mass of 717.43 grams of UBr6 for every 1 mole of UBr6. Okay, the reason that I put the number in the top is because remember I wanted moles in the bottom, so the moles and moles cancel each other out. So now that the only unit that's left uncrossed is grams of UBr6, that's what I wanted to figure out. Now I could calculate all this. Okay, starting with 100. Oops, 100. My next section, I have a number in the bottom. That means that I'm going to be dividing by 238.03. My next section is 1 over 1. I don't have to do that. And I have a number at the top, so I'm going to be multiplying by 717.43. And that gives me my theoretical yield is 301.40 grams of UBr6. Okay, so that would be my theoretical. So the question, remember, was asking for actual. So now what I'm going to do is I'm going to plug everything in here. So my percent yield was given to me 83% equal actual, which I do not know what that is. So I'm going to give it an X. Divided by my theoretical, which I just figured out, is 301.40 grams of UBr6 times 100. Okay, again, you could do this in many different ways, but the first thing I'm going to do is I'm going to get rid of this 100 by dividing both sides by 100. Okay, and when I divide both sides by 100, I get 0.83 equals X, which will be my actual, divided by 301.40. grams of UBr6. Okay, so now to isolate X, like in algebra, if X is being divided by a number, to get rid of that number, I'm going to multiply both sides by 301.40. So really what I'm going to be doing is I have 0.83, multiply that by 301.40, and that tells me that X is 250.16 UBr6. So this is my actual yield. Okay, if I want to check my work, what I'm going to do is I'm going to do actual. So 250.16 divided by theoretical, 301.4 times 100, and it should give me this percent yield, which 82.99. If I round it to a whole number, it gives me 83. So I am correct. Okay, so my final answer is that this is my actual yield, this is my theoretical yield. And number 8, if I start with 89 grams of sulfuric acid. Okay, so we haven't done naming acids, but remember that it says if I start with, that means that it's going to be on the reactant side, and we only have one reactant. So 89 grams H2SO4, that will be sulfuric acid. So if we start with 89 grams of sulfuric acid and we produce 7.1 grams of water. Okay, so this right here, and if we produce 7.1 grams of water, would that be my actual yield or my theoretical yield? Okay, there's gonna be my actual yield. Not my theoretical. My theoretical, I'm gonna calculate it using this 89 grams. Okay, so they gave me the actual yield for water. That means that I'm gonna have to figure out the theoretical yield for water. And the question is asking us for percent yield. Again, percent yield is actual over theo times 100. Okay, the first thing I'm going to do is I need to find the theoretical yield, because they gave me the actual, I have the 100, I need to figure out the theoretical to then plug everything in and find the percent yield. Theoretical, I find it using stoichiometry. Okay, so if I start with 89 grams of H2SO4, how much water can I produce? Okay, so my first step is going to be to do the molar mass of H2SO4. Okay, let me do it in a pencil. So the molar mass of H2SO4. So I have 2 hydrogens, 1 sulfur, and 4 oxygen. So 2 times the mass of 1 hydrogen, which is 1.01, times 2 is 2.02. 1 sulfur is 32.07. And 1 oxygen is 16 times 4, because I have 4 of them, is 64. I'm going to add all of them together, and it gives me 98.09. Okay? So this number, I'm going to put it in the bottom. 98.09 grams of H2SO4 for every 1 mole of H2SO4. The reason that I put grams in the bottom is so that grams and grams cancel each other out. Okay? Now that I'm in moles, now I could use the mole ratio to jump from one to the other. On the ratio here, if there's no number, if there's no coefficient, that means there's a 1. So the ratio is 1 to 1. So 1 mole of H2SO4 for every 1 mole of water. Okay, and like this, the moles of sulfuric acid cancel out. Now I'm left in moles of water. I want to know the theoretical yield, so I want to know the grams of water. Okay, so my next step is going to be to use the molar mass of water, which the mass of 1 oxygen, 16, plus the mass of 2 hydrogen, which is 2.02. That gives me a molar mass of 18.02 grams of H2O for every 1 mole of H2O. Okay, like this, the moles cancel out. Now I'm left in grams. So my final step is to calculate all this. Starting with 89. My next step, I have a number at the bottom, so divide by 98.09. My next step, I have 1 over 1, so I don't have to do anything. And then times 18.02. And that tells me that my theoretical yield is 16.35 grams of water. And that is my theoretical. Okay, my theoretical, remember I get it by doing stoichiometry. So now I'm going to go back to my question. So my question was asking me for percent yield. They gave me the actual, which was 7.1 grams. So 7.1 grams of water was my actual. That it's telling me that I produce 7.1 grams of water. The theoretical yield, I just calculated it, is 16.35 grams of water times 100. Okay, notice how the grams of water cancel each other out. So my final step is to calculate all this. 7.1 divided by 16.35 times 100. My percent yield is 43.43% of water. Okay, and that's my final answer.